All right, yeah, so, exactly. So, what we're going to do is we're going to take a look at some stuff way back from the first week, and then we're going to sort of work our way up on some of this. So, first things first, whenever you get a solve and it's got these values and things with it, all I'm going to do is rewrite what I have, and when I get to that particular letter, I'm going to go ahead and fill it in. And as I continue to do these, again, every time I see a variable, I'm going to go ahead and get that put in. So then, what we're going to do, and that's why they don't like them in the building. So, what we're going to do is just simplify everything piece by piece. So multiply the 6 and the 3, no big deal there. But here's the question. Is my next thing going to be to multiply negative 3 and negative 4, or to do this negative 4 squared that's right here? Which one? 4 squared. Because when we're doing order of operations, okay, parentheses are just when we have multiple things, like we're going to do the distributive property, and we're not doing that here. But the next one, the next highest power, is exponents. So I have to do this next. Nicely done. Because negative 4 squared is positive 16. And you're like, well, wait a minute. If I've got negative there, how all of a sudden is this becoming positive? Well, let's make sure there's one little detail, because again, I don't want you losing points on details on this test. Tests are too big to sit there and just lose a bunch of detail points on. Whenever you're trying to figure out a piece of something, what we're going to do is we're going to make sure that gets put into parentheses. Okay? So, what I'm going to do for the time being is get back to where we were here. Next question, but I think Caitlin had answered it before. I have two choices now. I can either do 18 minus 3, or I can do 3 times 16. Which one's next? 3 times 16, because multiply comes before subtract does. And I watch that sign because it's still minus. And that's one other thing I'll mention here. As we keep working on this, whenever you're on a test like this, the more you can show me what you've done work-wise, the better off you'll be. Because maybe sometime you'll get all the work right to here and you just put plus 48 instead, and you get 66 as the answer instead. That's only a little bit off because you did all the other stuff right. So the more you can show me, the better off we're going to be with these. Okay? So let's see here. Same type of thing going on in number 2, except, again, different values for our variables. But when I plug them in, I want to make sure the parentheses are there.
Somebody got your receipt.
So if they aren't, stay focused. I was going to say, you need to go get a drink, but I think you got one. Okay. So here, be cautious. And just go ahead and add those together. Keep life simple. You're like, do I even need to put parentheses if I'm just doing it here and I'm adding or subtracting? Not as much, okay? But here's where I've got to be careful on number 3. Back to our regularly scheduled programming here. When you go to substitute these in, here's the one thing I've got to be careful of on this one. Because there's nothing wrong with using the calculator, but here you want to do things in parts. Because here, when that big bar comes, and we've talked about this before, I want to do things separately. So here I'm just going to move to there. So here, if I do negative 4 minus 12, and again, if I want to punch it in the calculator, I can. Okay, I get negative 16, and then I can do the other part. But here's what gets interesting. What happens if you divide something by 0? Can you divide something into 0 parts? No. Uh-oh. So if I get this, it doesn't mean the calculator doesn't know what's going on. Doesn't mean that, you know, I don't get anything. It's just this is going to be no solution or undefined, or you could say it a lot of ways, but don't put 0 because that's different. Okay? So, that one, a little different. Okay, we had a chance to get through that one. Now here's some of yours nemesis, the fraction. So let's get this plugged in, then we can deal with this. And it's nothing bad. You're like, yeah, but how am I supposed to deal with the fraction? Well, I'll give you 2 options. One way we can deal with the fraction, we're just dealing with this part right now, is I can do a little work to the side. I'm going to turn that -6 into a fraction. How can I turn a whole number into a fraction? What number can I put underneath it? 1. So if I put a 1 underneath it, Troy, oh Troy. So when I turn it into a fraction, I can multiply across and get that part of my answer that way. Now that's not the answer at the end. I know this. But then again, think of it like you do money. I know y'all like money. If I borrowed $4 from somebody, I borrowed 6 more. Well, I owe them more. Now I owe them 10. You're like, okay, that's a lot of stuff to go through for one little problem. Isn't there another way? Yes. And here's the other way. Okay, let's get rid of this divide by 0 thing. I can, if I put it in parentheses, I can put my fraction in there. Okay, I can times by the -6, I can put it in, and then I just minus the 6 on the end. I can get the answer that way. Or you're like, well, I don't need all that, I just need this part. Okay, then just put the fraction part in that you don't like. Just type it in like you see it. Okay, there's the -4 part that we had. Again, it's not something that's impossible. You've got tools to use. We just got to use them, okay? So that's one thing. So then we got, which of the expressions below correctly shows the quotient of 4 and x? Ooh, what's quotient mean? You're close. If it said product, it would be C. Which one of those goes with quotient? D, okay? This one would be quotient. Divide is quotient. What's a fancy word for add? That starts with S. Sum. Excellent. Fancy word for subtract that starts with D? Close. Decrease is a good guess. D-I... F difference, okay? Those are 4 prime candidates to be on the test tomorrow, okay? One of those 4. So if you got a little feel for those, awesome. If not, we've done some sheets on these. Kind of just take a peek at it quick. I'm not telling you to like spend your whole night going over every sheet we've ever done. Just going over a little bit. So also, we're going to combine like terms. We're going to simplify. So I go through and I say, okay, here's just a plain old number. Where do I have another plain old number? Right here. But I have to be careful because that negative or that minus sign goes with it. So here, 7 minus 5 is 2. But here's the real question in this one. Can I put these two together? No, why not? I see it. Go ahead. Right, this one has a squared and this doesn't. So those have to just stay the way they are. Okay, it says simplify. We're not solving anything. There's not an equals anywhere. We're just going to put together the parts that are alike. And sometimes there'll be a lot of parts that are alike. Other times, not many parts that are alike. So let's see, what's alike in the next one? Okay, so these both have x's. So I got 8 of them, and at plus 19, because again, I'm watching the signs, gives me 27 of them. And again, I see both of these are just plain old numbers, so they can go together. But I got to take the sign that's in front. And again, if positive and negative numbers aren't your strength, use the calculator. There's no shame. It's not like I watch and say you get points deducted for it or something. I got 12, and I take away 3. I got 9 left, and I'm done. Again, keep things simple on yourself. Because I got all the confidence you can do this. It's just kind of putting your mind to it a little bit. Okay, number 8, I can read. Little distributing. Okay, if there's a number or a letter out there, we're going to multiply that through, because that's what distributing is. It's multiplying. So let's see. What's negative 3 times 2? Negative 6. Nicely done. Okay, it's got an x, so we'll keep it. What about negative 3 and positive 4? Nice. And that one's set. There's nothing to like to put together. Again, we got this. Oh, the dreaded fraction. The dreaded fraction. What are we ever going to do? Not do it. No. All right, here's what we're going to do here. When we have the fraction, again, it's kind of similar to what we did up in number 4. I can do one of two things. I can either say, okay, that's 1/3. This is 6x, and I'm just going to make it a fraction by putting it over 1. Because really, distributing by 1/3 is like dividing by 3. But if that confuses me, I can just make this a fraction. I can times straight across. So 1 times 6 is 6. 3 times 1 is 3. What's 6 divided by 3? 2. 6 divided by 3 is 2, so I got 2x. And I do that same thing one more time. What's that? Did you get something different? What did you get? Yeah, because if I put it as a fraction and then I just multiply across, I get it down to 1 fraction, and I go, oh, so really I'm just dividing that number by 3. What's 18 divided by 3? 6. 6y. And I'm set. And we're going to start getting into some problems occasionally that I'm going to ask you to write something out. So for instance here in number 10 it says what would be the first step in simplifying this expression? Okay, we're not solving, we're just simplifying. So what do you think we'd do first? Would I do 2 minus 4? No. Yeah, we're going to mess with the parentheses, and since I can't combine here, we're going to distribute, or you could say multiply, the 4 to the 3n plus 1. Or you could write parentheses, but I don't like trying to spell the word parentheses. It's too long. So I'll just write the parentheses here so I can say it. But again, you could use the word multiply as well, and it would work every bit as well. Okay, but it's just you explaining a little bit. Because sometimes when we explain stuff, it makes us think about it a little bit more where it would get done in a better way. Okay. And then number 11 is going to be really similar to number 8, except it looks like we got to do it twice, and then maybe, just maybe, we may have like terms to put together. But we'll see. So we're going to distribute. We're going to multiply that negative 5 times each part in the parentheses. So negative 5 times 6 is negative 30. Don't lose your x. Okay, if we lose our x, that could cause us problems when we go to combine like terms. Negative 5 times y is a negative 5y. And a couple of you have asked me, well, can I put plus negative 5y? You can, But I think with a lot of people that confuses them on what sign it actually is. So I'd prefer that you just put the minus in there. And then for the second one, we do the same thing, except it's a plus 3 that we're multiplying through. So 3 times 2 is 6. Thank you. And 3 times negative 4, a positive times a negative is a negative. And again, if that gets you, let the calculator help you with the number part. Okay, I don't have to plug the variable part in. So once I get here, what terms can I put together? What ones are like? Yeah, my x's are the same. And again, be cautious. I owe somebody $30. Whew. I pay him $6 back. If you're not sure, just think of it this way. 30 minus 6 is 24. Which number is bigger? Well, 30 is, and it has a negative. Okay, so my answer is going to have a negative. Same thing working with my y's. I just keep working with the fact that it's a negative. If I owe somebody $5, now I borrow 12 more, they're the same. They're both negative, unfortunately. So I'm going to add them up, which is 17, but I'm going to keep the sign. And I get that set. And we're good to go. And again, that's all we're doing on those. Little multiplying, little putting together things. And again, if you're not sure when you're adding them up, let the calculator help you out. It's okay. Move this up a little bit here. Okay, translating. So again, when we figured out what all those words meant up top, that's going to help us now. The sum of x and 4. What did we say sum was? Addition. So we're adding x and 4 together. So let's see here. 5 times, well, I know times is multiply. The difference of x and 3. Now what's difference? Subtraction. And whenever I see the word difference or I see the word sum, I'm going to put that part in parentheses, because here's why I got to do that. So I got 5 times x minus 3. If I didn't put the parentheses, I'd do 5 times x and then minus 3, and that's not what it says. So sum and difference, we like to use the parentheses just to try and help us out some. All right, here's the one for my experts. 8 less than a number x. I have a choice. Which one is it?
The one on the wall.
Ooh, I'm getting votes for both sides. If I want to take 8 away, if I want 8 less than, yeah, it's got to be the first one. Okay, sometimes you might have to talk it out with yourself a little bit. You might even have to stick a number in here for x. Maybe you say 8 less than 10. Well, if it's 8 less than 10, it'd be 10 minus 8. Oh, okay. Make it, make it real where it makes a little sense. Now this one, I gotta admit, is a little tricky. 8 is no less than x. And if I haven't mentioned it before, any of those note sheets some of you got, and some of you put them in your homework check, so we'll have to get them out. You can use those on the test tomorrow. Okay, note sheets, yes. Tomorrow, yeah, the test is tomorrow. That's what this preview is to get us ready for. So, now I can't use the homework, but anything that says notes I can use, okay, to try and give me some assistance. So, you've got a couple of sheets that might help you here. 8, okay, we got x. Now we got to figure out, it's going to be one of those inequality arrows. Is no less. So it has to be more. No less. No less. Which way is my arrow going to go? Oh my gosh. Sure. Is it Now you're like, now how do you know that? Well, let's make it real. Let's say I put the number 9 in here for x. 8 is no less than 9. Where you're like, well, that doesn't make any sense. Okay? And it'd have to be the other way. So put in a number that's less than 7. Okay? So is 8 greater than 7? Yes. Okay? So I can put a number in and make it work for me. Just something to ponder. No, I'm just saying, yeah, I'm just making up a number that makes it true so I can think about where that arrow's got to go a little bit more. Yeah, I'm not actually putting a 7 legitimately in there. Now this page printed kind of funny. All right. Joe wants to buy an iPod Touch. It will cost him at least $150. So now at least. Does that mean it might cost him less than that or it might cost him more? Okay. So it could cost him more. If X represents the money he needs, write an inequality to show how much he needs. Well, we know there's 150. So if I want more, I could, but this one's got to be an arrow. Yeah. X is going to be greater than. If the arrow is eating X, that means it could be more than that. So X is going to be greater than 150. And it might even be equal to, because it says at least, it doesn't say more, it says at least. So that's how I'd have to look at that. Okay, if it's going to cost more, arrow eats X. If it costs less, the arrow is going to point at X. Let's see what else we got here with the story problems. The Smiths pay $1.25 for rides at the fair plus a $5 fee for entrance. Write a variable expression for the amount of money the Smiths pay based on the number of apples they buy. What? Rides they ride, apples they buy. What the hell? I have no idea where that apples thing might come from. Okay, so let's see. Which one of the numbers depends on how many rides I do? The $1.25 or the 5? The $1.25, because the $5, I got to pay the $5 whether I ride any rides or not. Okay? So this one doesn't change. This one does. Okay? Anything that can change based on the number of times I do it's going to be my X. So I look and I say, okay, let's see. 5X plus, no, the X isn't with my 125 on that one. Yeah, because the other two don't even have a 125. So it's got to be this one. And sometimes I can get it just by process of elimination. All right, let's see what else we got here. Word problems are coming to an end, but the temperature was at 50 degrees and began to fall 5 degrees each hour. If it's falling, is it going up or down? Down. Write a variable expression for the temperature based on the number of hours that have passed. Okay, so it started at 50 degrees. And let's say it had been 3 hours that had passed. You'd be like, well, it'd be 50 minus 3 times 5. If 3 hours would have passed. You're like, where's 3 hours? I'm just saying, for example. Huh? Yeah. We're going to replace that value with, oops, 5x, Harty. 5x. Because it's going down 5 degrees every hour. So if it was 3 hours, I could have 3 times 5. If it was 2 hours, I'd have 2 times 5. And it's flexible for me. It's not just for the one time. And then we're pretty good and we're good to go. So let's see here. I think we're coming towards, yeah, we're getting. Well, if you've been doing it along with us, it's going to be in the next homework check, but it's almost like a freebie because we're doing the whole thing together. It's not too shabby. Oh, so. Yeah. So here, okay, if I'm trying to get X by itself, whatever I'm trying to get by itself, come on, box that in. How do you get rid of a positive 10? How do you undo a positive 10? Negative 10. Negative 10. And I do it to both sides. Now my X isn't quite alone because that negative is like having a negative 1 there. So since, let's see, I got negative 1 times X equals 5. What's my last undo to get x by itself? Divide by -1. Make sure I get the negative, because otherwise my sign might get messed up. And a positive divided by a negative is a negative. You're like, all right, yeah, I suppose. Not too awful. But on all of these, any equation, your first goal is always to get that part, or what's called that term, that's with x by itself. How do I undo a +4? Negative. So I'm going to -4. Those go away. So now one step to go to get x alone, and I'm multiplying it by -7. How do I undo multiplying by -7? Divide by it. Now here's the kicker, and we're going to put a note in here so we don't forget this. You're like, wait a minute, why is the arrow going the other direction? If you either multiply or divide both sides by a negative, and we did that right here, you have to flip the arrow. Okay, but only if I do it to both sides. If this were just -7 and that was +7 and I divide, I wouldn't flip it. Only if I do it to both sides. Then I got to give the arrow the old flipperooski. But otherwise, everything stays the same. But you'll start to notice a pattern here with all of these, that we keep doing the same idea. It's just, can I do the undo part? Okay? There's where my x term is, 2x. I don't like the 8, but I'm looking at what am I doing with the 8? I'm dividing by 8. How do I undo dividing by 8? Times by 8. And I'm going to do it to both sides. Whatever I do to one side, I got to do to both. I got to be fair. Now I got to be careful on the left. That 8's whole job is to just get rid of the fraction on this side. So I got 2x, and 5 times 8 is 40. What's my last step to get x by itself? Divide, because I'm multiplying by 2, and that's how we undo. Nicely played. And I'm ready to roll. And I can almost use 21 as a helper for 22, because here's my term where x is, x plus 5. Just like I did in 21, my first problem is I'm dividing by a number. So just like on the last one, I got to times by 3. Whatever's left up top is still there, but 4 times 3 is going to be 12. Now this time, what's my last step going to be? I'm not dividing this time. Minus. Nicely done. So you'll notice I start to do some things on here several times. Just see if you're kind of awake and with me here. Same thing. Box in that variable term you want to get alone. Whatever's not in the box, I got to undo it. How do I undo what's not in the box? Get that 8 on out of there. Don't forget this one's got an arrow. It's an inequality. Don't turn it into equals. What's my last undo? Divide by the -4. Oh, wait a minute. Divide both sides by the -4. What do I need to do? Yes. Divided both sides by the negative like we did up in 20. Got to flip the arrow. Flip it, flip it, flip it. Like, all right already. But again, this is what equations are all about. Get the term by itself by undoing everything else, and then it gets easier. Undo that minus 6. We got this. Now this one's a little more interesting. Because you're like, well, now what do I do? I got to multiply by 2 and a divide by 3. We'll always take care of the fraction first. So since we're dividing by 3, we're going to times by 3. So I got the 2 that's up top left still. 21 times 3 is 63. And yes, you can get a decimal for an answer. It doesn't mean you're wrong, because that's exactly what we get this time. Okay, so don't doubt yourself. If you're doing undos with opposites, and you're doing everything right, and you're feeling good, and you get a decimal, that's okay. So let's see here. We got another explanation come in. All right. So we're going to do the problem. Let's just do the problem here, and then we'll put the explanation down. All right. There's my end term. What's my first undo? Okay. So the opposite of -4 would get me a plus. Okay, because that would wipe that out. But you're right. And then what would my last step to be to get n alone? Think about what you're doing to it and then do the opposite to undo it. Multiply. Perfect. So here's what we're looking at as far as an explanation goes. What did I do? Well, let's see. Let's see, I added 4, but I got to make sure I say I'm doing it to both sides, because this would be like what you're verbally telling somebody to do to solve this. So add 4 to both sides. Multiply 3 to both sides. Okay, that's all I'm looking for. I'm not looking for anything fancy. I'm not looking for a, 3-paragraph essay. Just a couple of little short statements explaining how you would do this. And you nailed it. Okay? All right. Last page. So you're like, thank goodness. Oh, yeah. Oh, absolutely. But you start to see some repetition with these, and that's on purpose. I'm just trying to make sure that I've got you all kind of into a groove here on how everything's working. All right. Last part. All right, story problems. We got this. Write an equation, write your answer. All right. Jessie spent 1/3 of her savings on a new coat. The coat cost $60. How much were her savings before she bought the coat? How much were her savings? That's what I want to know. And it says here she spent 1/3 of her savings. So 1/3 of her savings on a new coat, which costs $60. So that's my equation. How do I undo this? How do I undo this divide by 3? Multiply. And it's actually the only step I'm going to have to take, because 1x and x is the same thing, which tells me she had $180. So again, when I write my final answer, Jessie had $180 before she bought the coat. And that, again, not looking for a paragraph, just a sentence to explain what was going on. But again, sometimes it may even come down to writing something down in regular English form before you can get it into an equation. 27 might be a good example for that. For babysitting, Mary charges $2 an hour plus an additional $5 for transportation. One evening she made $21. How many hours did she babysit? Okay, let's think about this for a minute. So she's going to do transportation plus what she gets hourly is going to equal the total. And you're like, now why would I want to write all that out? Because sometimes we just start looking at numbers like, I don't know where this stuff goes. Shoot, I'm just going to skip it. And instead, I can look at this and say, okay, now what do I know? I know I get $5 for transportation. Doesn't say about how far or anything, so I guess I just get $5 no matter what. Then, there's the magic word, $2 per hour. So if I work 6 hours, it's 6 times 2. If I work 1 hour, it's 1 times 2. And they even tell me how much total she got. Oh, there's my equation. 5 plus 2x equals 21. I just put it into words first so I could kind of wrap my head around how this is working. So I look and I'm like, okay, I've done these. I need to get my x term alone first. What's my first undo? Subtract 5 or minus 5. Excellent. I think I'm going to take up my b here a little bit, but that's okay. So good, we've got our x term isolated, so now how do I get x alone? What's my last undo? Divide. Mary babysat for 8 hours. It's a sentence. Keep it simple, keep it simple, keep it simple. All right, last one. Mr. Harper makes a profit of $10 on each shirt that he sells. Each shirt. Depends on how many he sells and how much he's going to make. How many shirts must he sell to make a profit of at least $220? Okay? So I know he's going to sell a certain number of shirts. I know how much they cost. Okay? So this is a typical cost times quantity equals profit. This is what every business person does. I'm like, okay, so I make $10 times the number of shirts, but I don't know how many shirts. But if I'm going to make at least $220, I'm kind of set. And my final undo of this monstrous packet lets me know that I have to sell at least 22 shirts if I want to make that much money. So let's see. Mr. Harper must sell at least, I got to get the word in there, 22 shirts to make $220. Now again, and I'll just say it one more time just to be sure. When you come in tomorrow, your Unit 1, Part 1 test here will be 28 questions. They will set up just like that. You have basically a copy of the test in your hand. The only thing I'm tweaking is some numbers. So please, whether it's just a couple minutes before bed tomorrow morning when you wake up and you're eating breakfast, I don't care. Look at this long enough so you can kind of have it fresh in your brain so when you come in, you are ready to roll. And this will be online too.